Good morning. I got 17 minutes into this video when I miscopied an X as a Y and completely ruined the word problem because I miscopied an X as a Y. And so I am starting over from scratch. Yep, that's frustrating for me, but we're going to make the most of it. So we're going to pick up with our systems of equations by substitution lesson with our last example, just kind of illustrating how the systems work. I am going to depart a little bit from what's in the copies of the class notes, and that is for a specific reason. So we're going to look at this system, negative 2r plus t equals 3, and 5r minus 4t equals 6. If you think back to the last lesson, I said, when do you use substitution? Because substitution does not work well all of the time. There are times when you actually don't want to use this strategy. And the answer to that was when one of the equations is solved for one of the variables. In other words, you have x equals y equals, it's already by itself. Or it's easy to get one of the equations solved for one of the variables and you won't have to do a lot of steps. In this example, none of the variables are by themselves. We don't have r equals and we don't have t equals. But if you look at the top equation, the t does not have a coefficient, or it has a coefficient of 1. So it's like almost by itself. So if I take that top equation there, negative 2r plus t equals 3, and I just add 2r to both sides, negative 2r plus 2r is 0, and then bring down the t. Now remember, these are not like terms. You have something with an r and something without an r, so you cannot combine them, but you can just write 3 plus 2r, and in that one quick little step, now I've gotten one of the variables by itself. And so this would be an example of an equation where they're not solved for one of the variables, but it's pretty easy to get one solved. Now, when you go to plug in the equation, it's important, especially in this kind of case, it's important that you plug it into the other equation. You don't want to plug an equation into itself. So you don't want to take your t and plug it into the equation that gave you that expression in the first place. What that will do is it will result in something like, 5 equals 5 or 0 equals 0, and it'll do that every single time, and it won't get you anywhere in the problem. So you do need to plug into the other equation. I'm going to do this just for today. It's the last day I'm going to do this. That's a little bit messy, where I highlight what that substitution is going to be. And so I'm going to take out the t and replace it with something of equal value. That's the idea of the substitution. You replace the sugar with the Splenda. It's going to sweeten your pumpkin pie in the same way. But it's different in some kind of key attribute. And so with the pumpkin pie, it's different in that it doesn't make a diabetic's blood sugar go up. In a mathematical equation, the importance is that I've gone from having two variables, an r and a t, to having one variable, which is just the r, and that kind of equation we know how to solve. Now we kick in our equation solving skills. Bring down the 5r, distribute, don't forget to distribute the negative 4, okay, it's the negative, so negative 4 times 3 is negative 12, and I can't write that, and negative 4 times 2r is negative 8r. Combining like terms, take care here, that's still one of those sore spots. People want to add 8r to what? To the same side twice? Don't do that. 5r minus 8r is negative 3r. And then we add 12. And you don't have to write this plus 12, okay? I'm doing that for clarity. 6 plus 12 is 18, and then we divide both sides by negative 3, and we get r equals negative 6. Again, remember what you're looking for. What is the solution to a system? It's the values of the variables that make all the equations true. Right now, I only have a value for r. In order to solve this, I need to have a value for t as well. Now, you can plug the r in. We're going to do another substitution. You can plug it into either of the original equations, or you can plug it into the rewritten equation. When I was in school, I was discouraged from doing this. I think under the idea that if you made a mistake in solving this, like for the t, but I'm kind of thinking if you made a mistake solving that for t, then this whole number is wrong anyway. So I don't know why we bother. So this is the easiest place to plug it in because it's already solved for t and you don't have to do the algebra on the other side. So I'm going to do the quick little rewrite again where I change up the color. Okay, we'll flip-flop it. We're going to take out the r and substitute it with something of equal value, which would be -6. But different in that it no longer has a variable, which is kind of where we were going with that. Make sure you use your order of operations here. So you have to do multiplication before you can do your adding. 2 times -6 is -12. And then 3 minus 12 is -9. Now you can leave your answer like that. That is an okay way to leave your answer. R equals -6, T equals -9, everything is fine. If you were asked to put it in an ordered pair, okay, so something like XY, then you're like, well, wait a minute, I don't have an XY, I have an R and a T, which order should they go in? The idea is that they do go in alpha order, unless you are told otherwise. So in this case, the R would come first because R comes before T in the alphabet. And so you would say -6, -9 as your answer. If you were asked to do it in an ordered pair, or if you were taking a multiple choice test and they were in ordered pairs, that's how you would determine which number was the R and which number was the T. Now, really quickly, I do want to show you what happens. I mentioned it out loud. But like what happens if you plug the equation into the same equation that you got it from? So if you took -2r plus t equals 3, and then you solved that like we did over there on the right, and we got t equals 3 plus 2r, and then you plugged it into the original equation instead of into the other equation, here's what would happen. So you're like, okay, I'm going to take out my t. It seems like such a great idea until it doesn't work. And then you realize that wasn't a great idea. Okay, now these parentheses are cosmetic. Something that came up in, I think it was on your test when you had to find the mistakes in your Unit 1 test. Finding the mistakes. A lot of you cited like certain kinds of parentheses as being mistakes when they weren't. Right here, the parentheses they're cosmetic, meaning they make a problem appear different, but they don't actually serve an algebraic purpose. So here the parentheses are just kind of saying that this whole chunk of stuff came in as a group. But if you think about what's happening here, like you just do +3 plus 2r, it doesn't do anything. You could say we distribute the plus sign. Well, that's nice. That doesn't do anything. So you don't have to put the parentheses there. There are times in algebra where I will put parentheses in cosmetically because they change the way something looks and they change it in a way that's valuable for us, but it doesn't affect the math. Now look what happens here. We have -2r plus 2r. And -2r plus 2r is 0, and it leaves me with 3 equals 3, and it doesn't lead me to the solution of the problem. And so that's why you want to make sure you're plugging it into the other equation. When you plug it into the other equation, it's possible you could still end up with 3 equals 3, and in that case it means something different, but make sure that if you're going to get that, you get it by plugging it into another equation. All right, the last problem in this lesson is a word problem. We're going to talk our way through that word problem, and then we will get into some practice work. So a word about word problems. I actually like word problems. I am an engineer at my heart, not a mathematician. And so I don't like math for the sake of math. I like math for what it does and what it helps us figure out. And so when it comes to word problems, I like them because I get a chance to see how this math connects to something that I might observe. That being said, systems of equations, word problems, are like kind of the dumbest things ever. They are very contrived. And by contrived, I mean they're made up in a way that is totally unrealistic. And all I can really tell you about that is that they are good practice for when you will encounter more complicated systems in your science classes later on. Because systems are very, very useful. It's just some of the situations where they arise aren't good for practicing. And so we practice on these very contrived problems. So let's go ahead and read this and you'll see what I mean. So Stan's student has some $1 bills and some $5 bills in his wallet. He has a total of 15 bills that are worth $47. How many of each type of bill does he have? So what I mean when I say this is contrived is that in any kind of real life situation, you would just look at what Stan had in his wallet and you would answer the question. He has 10 $1 bills and 2 $5 bills or whatever. You wouldn't ever try to figure this out algebraically. And in so many of the word problems that you'll see, realistically, you're not going to figure out what the cost of the adult ticket is. You're going to look at the posted prices because people don't hide them from you. As you might experience a bit of frustration with the absurdity of systems word problems, just keep in mind, like, this is good practice for interpreting the words, translating them into mathematical equations without the problems getting too complicated and messy, and save the complicated stuff for when you encounter them in a chemistry class or a physics class. All right, so that little spiel is over. When you are reading a systems word problem, there are always two pieces of information you're given, and each piece of information gets its own equation. In this problem, here are the two pieces of information. We have a piece of information telling us the number of bills. Okay, and I'll underline it. He has a total of 15 bills. That's going to be one of our equations. How many bills does he have? So let's go and assign some variables to that. Now, I would love to say that $1 bills are the O and $5 bills are an F. O for 1 and F for 5. The problem with that is that a lowercase o is a terrible choice of variable because it'll look like a 0, and we don't want that. And so in this problem, we probably should go with an x and a y. The tricky part of that is remembering which is which is what I messed up with the first time I recorded this video, because I didn't keep it straight. And if I'd been using O's and F's, I wouldn't have had that problem. If this were like $5 bills and $10 bills, I would absolutely use an F and a T. But let's go ahead and we'll use X for the number of $1 bills and Y for the number of $5 bills. So the number of bills is 15. So the equation would be X plus Y equals 15. If I take the number of $1 bills and I add the number of $5 bills, I know we have 15 bills total. Now I'll switch up the colors here. The other piece of information, because I said there's always two pieces of information that we're given, the other piece of information is the value of the bills. And we know that the value of the bills is $47. So those are the two pieces, and I'll underline that in the purple so you can see that. So now I have to figure out how do I express the value of the bills in terms of X and Y? Well, if I have X $1 bills and they're each worth $1, then I would do 1 times X. And then I have so many $5 bills, and those are each worth $5, so I would do 5Y. We'll stop and think about that for a moment. Don't just write it down. Give your brain a chance to think through it. So take all the $1 bills, multiply them by 1. It's kind of redundant. And take all your $5 bills, multiply them by 5. And if you add the value of the money up together, you should come up with $47. All right. So this is actually a really good system to solve by substitution, and you have a lot of options for how you can solve one of the equations for one of the variables. All of the following are good. You can take the top equation and solve it for X, the top equation, solve it for Y, or the bottom equation and solve it for X, because remember 1 times X is just X, and I only put the 1 there because we were talking about $1 bills. When we're doing this in class, I will usually ask the class, what do you want me to solve for? And I will follow whatever their lead is. Just make sure that when you answer a question like that, you specify the top equation for Y or like the left equation, depending on how it's written on the page. I have in the notes, so I'm consistent with what the notes are doing, I have take the top equation and solve it for y. So we're going to take this y and try to get that by itself. So I have x plus y equals 15. I subtract x from both sides, bring down the y. These are not like terms, so don't combine them. They just sit there as 15 minus x. Then plug that into the other equation. Don't plug it back into itself. Plug it into the other one. So we have 1x plus 5. This is the last time I'm going to do that, where I change the color up. And then we're going to take out the y and replace it with something equal to y, but different in a key way. Namely, we're going to get rid of that extra variable. And now we have an equation that just has x's. Notice I did drop the 1 off of the x. You can do that or not do that. Go ahead and distribute. So 5 times 15 is 75. And then 5 times negative x would give me negative 5x. Bring down the equals, bring down the 47. Take care when you are combining your like terms. That is x minus 5x, which is negative 4x. Bring down your plus 75. Then we're going to subtract 75 from both sides. Please use a calculator for that. That's a little bit too big to do in most of our heads. You could flip it around and do like 75 minus 47 and just remember that the sign is negative. But if what I just said sounded like some foreign language to you, then don't do that. You are allowed to use a calculator for this class. So when you see something like that, especially if you know you tend to make mistakes with signed numbers, just find your calculator. It is negative 28. Divide both sides by negative 4, and I get x is equal to 7. Okay, I'm making sure, like, this is where I flip-flopped it in the first time I recorded it, and for some reason, I took the x and I made it a y instead. And so my numbers of the $1 and $5 bills, they were 15, but they didn't add up to $47, and it was very frustrating. Okay, so we know that x is equal to 7. That doesn't finish the problem for us because remember the solution is to find the values of the variables that make all the equations true. I'm going to come over here. I'll point with my pointer thing. I'm going to come over here because that's where I have some space and it's also set up for some work there. I am going to plug in my x value, which is a 7, and 15 minus 7 is 8. And so we have the following, because I have no other place. This is like what bugs me when you guys do this on your homework, and here I'm doing it. So do as I say and not as I do. But hopefully on your homework, you're not restricted to an iPad mini for the amount of space that you have to work with. Okay, so what do we know? We have 7 $1 bills. Try one more time. 7 $1 bills, and we have 8 $5 bills. And you could check that by figuring out the total of the money. So 7 $1 bills would be $7. And if you have 8 $5 bills, that's $40. And then 7 plus 40 is the 47, which of course is what we knew the value of the bills was. And then I was actually at that spot where I was going to figure out the value of the bills, and it came out to $35, and I thought, that is not what it was supposed to be. Again, just, it happens to everybody. Like I flipped an X and a Y, and I had to start the problem over. Don't be discouraged, like when that happens to you. It's not if it happens to you, it's when it happens, and you just, erase your work and you start over and don't make a big deal about it. Before we leave this and we get into the practice, I do want to address one other question. And I want to address this because I think too many students write this off as not real math when it is real math, and it might even be a good way to do the problem. And that's how else could you figure this out? If I were to give you a problem like this on your test and you know that maybe you're not great at writing those equations, or it's just not coming together for you. And what you don't do is you don't say IDK. You don't put a question mark there. You don't quit. You try to figure it out some other way. And this goes unutilized. And that's your guess and check method. And that is okay math. And in some cases, it's actually better than doing what we did. Take a look at this. Look at the amount of work that went into answering this question algebraically. You could really make a good case that this is an inefficient way to do this and that you could come up with the answer a lot faster. The tricky part with guess and check, if you want to get credit for it in a math class and you're asked to show your work and you only dump out the answer and I say, okay, Stan student, how did you figure this out? And you're like, oh, I guessed in my head. That's not going to wash because you could guess with photo math or guess by looking at your neighbor and seeing what your neighbor got. So if you are using guess and check, you want to write down some of that process of the guess and checking. So it could look something like this. So he has 15 bills. You could say, well, what if he has 5 $1 bills and 10 $5 bills? Okay? And you actually write down what your guess is. Well, this would be $5 and this would be $55. No, 50. I did the adding in my head there. A little bit ahead of the game. All right, $55, and that is too high. So if it's too high, then you need to bring down this and bring that up. And you say, okay, my next guess, let's do 7 $1 bills. And so I brought that up. So that would be 8 $5 bills. And so that's $7 plus $40 and you got it doing just like 2 guess and checks. You just pick something and then you make the adjustment. Just make sure if you're doing a strategy like that you are writing down, like maybe indicate that you are actually using guess and check. You can just say GC for guess and check, and that you're writing down like what your guess is and then how you're adjusting your guess after you've checked it. So your $55 was too high, and so you're going to adjust a little bit. We could have gone for like $6, 6 $1 bills, and that's bugging me. There we go. Okay, fixed. And just indicate that process going through. And if you're lucky enough to guess on the first try, actually write that on there. Like, Miss Taylor, I was going to do guess and check, and I got it on the very first try. It does happen. It doesn't happen a lot. But for a lot of you, this is actually a lot easier and a lot faster than this process here. And part of being a good math student is learning yourself and what strategies work for you under what circumstances and learning how to express yourself with those strategies the best way possible. All right, last up is finally for you guys to get some practice on your own if you didn't practice with some of the homework. I'm recording this like weeks in advance, so I have no idea what that homework might be, but I'll figure it out before we get to this. Anyway, here's some practice problems. Now notice that I'm giving you the answers. I am aware that you can take a picture of these and PhotoMath will give you the answers. Just as a warning about PhotoMath though, PhotoMath solves systems of equations in a really jacked up way. And so if you copy down the work that you're showing for PhotoMath, I am going to know that you used PhotoMath to solve your math homework for you because it does it in a really weird way that no human being would ever solve a system of equations. So don't use PhotoMath. I'm giving you the answers because I want you to know whether or not you're getting them right. And that way, when you're asking a question, it's because you've got something wrong. So we'll stop here, write down those problems, work them out, and then we'll look at some of your work and I'll answer your questions as needed.